Yeah, it came out of beta last year in 2022, and yeah, it's available in App Store Connect, of course, also in Xcode, and through APIs from App Store Connect. Yep. So some selected history. I picked out some nice things, because first there was Xcode server, right? Xcode server first ran on the macOS server, and I don't know if you remember that. I see some nodding here, so that's fun. Yeah. And later it got bundled with iOS 9, but it was very cumbersome. You could only use one build, and you could connect multiple agents, but they could only marginally connect with Git and different branches at the same time. So if you had a regular branch, a feature branch, and you want to do a PR, it was very hard to connect it to the server. And then BuddyBuild came along in 2015, made it all very easy, also online. I remember that the first builds we did were around 45 minutes, but yeah, it got better and better in the course of the years. And actually, in 2018, Apple thought, oh well, looks good. Our solution is not good enough yet, so we're going to acquire BuddyBuild. And well, then everything went silent. We didn't hear for it for 3 months or 3 years even. And then finally they announced Xcode Cloud in 2021, and that was also the end of BuddyBuild, because then they also sent final notices to everyone saying, hey, we're going to discontinue, and you should wait for WWC. So yeah, at NOS we also used BuddyBuild until I think March 2021, till it died, and then we moved over to Bitrise, because that was the most logical and most popular platform at that time. But yeah, we still had some interest in Xcode Cloud, and we beta tested it since the first announcement. The first builds we had to wait for like 2-3 days before a build came through. But yeah, also that improved, and at one point, yeah, we moved over some of our apps. So in 2021, before it came out of beta, we saw that it really got better, and so we decided to move our release process to Xcode Cloud there. Later, we added PR hooks for the NOS app, and yeah, then moved over the other apps, and finally we moved over our private frameworks as well. We have around 15, I think, and yeah, those we also build with Xcode Cloud, and I'm going to tell about that later as well. So why did we choose Xcode Cloud? Well, it's very easy to use, because yeah, basically when Xcode Cloud came out, it obsoleted everything with certificates and provisioning profiles and stuff. That was the first reason. Then it had first-party test flight integration, so that was a big plus for as well. Then we found that the speed was faster than Bitrise. We had a three-machine Bitrise setup, but yeah, we found that our builds were faster actually on Xcode Cloud. And the pricing was a big thing, because on Bitrise we paid like 3,000 euros a month, or a year, I mean, and we came back to 600 euros on Xcode Cloud. So that was also a big reason to move to there. And of course, yeah, it's built by Apple, so yeah, it's yeah. So a little more about pricing tiers, right? You have a free tier right now. It's still free up till at the end of December. Then it's 15 euros, 14.99. And you also have a 100 build hour tier. That's 50 euros. Then 250, that is 99.99. And then the last one is 1,000. But yeah, that's $400, I think, or 400 euros even. But we use the 100 because we have enough for our apps for 100. So yeah, that's why we chose it. Yeah. So let's get started. Yeah, Xcode Cloud works by creating workflows, and workflows you probably know as well from Bitrise. You can click each step into a full automated system, and that works about the same with Xcode Cloud. And you can also have multiple workflows per app. So we use one, for example, for PRs, and then another one to release. And it's very easy to set up. I will demo it later and go through the whole process, and you can see, yeah, it's just super easy. And yeah, and one of the reasons for that is that it's integrated with Xcode itself. So yeah, like I said, workflows can have multiple steps, and yeah, that's what I just said. Yep, and the first is the starting conditions. So the starting conditions are branch changes on your Git, tag changes. So if you add a tag to your Git, then yeah, Xcode Cloud will pick it up and then start workflow. Pull request changes, of course. So if you create a pull request, Xcode will hook into that and create a build process for that as well. And the last one is also scheduled. So if you want to do nightly builds or something, yeah, there's an option for that too. Second, of course, you want to do stuff. So you can do a build, and you can run tests on various devices. You can select which devices you want to run the tests on. And you can, of course, archive your app. And that's useful because afterwards you can also then send it to test flight and, of course, also notify Slack or through email. So under the hood, it looks like this. So you have, yeah, Xcode spins up a temporary environment for each build process, and clones the repository, and then you have the green step. Those are build steps. So you have a post clone step that is built with a script. Actually, a script is run. That could be included in your project, and I will demo that as well. Then it resolves dependencies, so it downloads, for example, SPM packages and stuff like that. Maybe something else. And then it does a pre-build step, so you can then process those dependencies, maybe do some stuff with that. Yeah, and we'll see some example of that later as well. And then it runs, of course, the Xcode build command. So it runs Xcode build test or archive. Then you have a post build step, and then it saves artifacts and goes to the post action phase. So, like I said, there's 3 kinds of build scripts. So you have the post clone, that is to install a tool or something. Yeah, or maybe add an entry to a new property list or something like that. And then pre-build is used to build additional dependencies, maybe. And then you have post-build. So even when the post-build fails, it will still execute, or the build fails, it will still execute, and you can then use it to process artifacts, stuff like that. So now it's time for the demo. So I'm gonna, yeah, sure.
Do you also have ways of canceling stuff?
Yeah, for sure. Yeah, if a test fails, for example, you can choose to ignore the rest of the thing. Yeah. So I have to switch to Xcode now. Let's see how that works. Like this, and then I have to do a mirror. So this is Xcode. I hope it's all readable from the back as well. And yeah, I've got a little app here. Let's run it. It's just a demo app that I created. This one I don't need. And yeah, it looks pretty much like this. So it's just a list of Marvel characters. And yeah, when you click on it, it shows a detailed picture. Not very special, but it serves our purpose. And I'm going to try to get this to the Xcode cloud. So here, let's see. Oh, nice. I killed the simulator. It doesn't like that. So here there's a little icon, right, with the cloud and the dot. And I'm going to click on it. And then I'm going to say, get started. Zoom out. And yeah, then I can click on here, kind of select my app. Marvel Catalog it's called. Click on next. And then I can construct a workflow. And Xcode already gives me some default options. So, for example, this one triggers on branch options or branch changes. So if something in a branch changes, in this case the master branch, then it's gonna trigger my my workflow. It runs on Xcode 15. That's fine. And the actions, I want to edit that. I want to actually just build it, not archive. So I can click here on the plus, just say build, and then I'm gonna delete this one. Let's see how that works. It's so very hard to read. Right at the top. Oh yeah, the waste bin. Yeah, nice. Okay, so like this. Yeah, and I'm fine with this. So let's go save it. Next, and then it's gonna upload it. Gonna connect the GitHub account. I already set that up earlier, so it remembers. But yeah, you go to the authorization step here normally. Just yeah, Xcode will guide you through that as well. Go link to GitHub actually, so that you only have to press approve to allow it. It's very nifty. Press next again.
Sorry.
Yep.
Was that also through GitHub or through some other?
Yeah, we use Bitbucket, and for our new Yoshino app we use GitHub. Yep. So we're in the process of moving. Yep. And then yeah, I have to press complete, and then it's done pretty much. And this is nice. Nice. I know that it's actually, I think it's created already a workflow. Try again. See what it says. Probably the same. It's a live demo, right? Yep. There we go. Yep. So here I can also say start a build, and then it will start. And now we wait, right? No. Here's the list, and here we also see a new tab. This one, and it has here a cloud tab, and I can zoom in on this a bit. And here we see the workflow, and this is the master branch and one build. Then we have the overview, and you see here that it's waiting, setting up an environment. You can follow it in real time, pretty much. So let's do it. I know it's gonna fail, so that's nice. Fetching the source code. Here you see that it checks for a post clone script. It's not really there. So now it's running Xcode build. We're gonna wait a bit, and then it will probably say, "Hey, I don't get what you are trying to do." Yep, here it goes. So we can peek into the logs here, and it says, "Well, you don't have a Marvel credentials file." And the Marvel credentials file, that's a file I have here. Oh. It has the credentials to connect to the API, right? And I don't have that committed into my source code. So how are you going to do that? Well, let's try to create a build script that creates a plist with these values, right? So I'm gonna create a new file. Go to script, shell script, and I'm gonna call it. I just have to make a new folder. And that folder has to be CI_scripts. And then I'm gonna call it CI pre-built. I think I'm gonna check on it what it's supposed to be. Let's see in my notes or my Git. CI_pre-build Xcode build. Okay. Ah, that's a good question. I'm not sure actually. It did actually, yeah. But I would like that to be in the project as well for ease. So I'm just gonna do this. And just remove this, remove reference. So there we go. Okay, and we decided that it needed another name. And oh, it was this one. So CI underscore x pre underscore Xcode build. Right. So like I said, we have to add these things to the plist, right? But how do we get them? That's a good question. And we need to add them to environment variables, actually. Going to the workflow here, manage workflows, select the default, and then here there's a tab that's called environment. So we're gonna just public add them here. So public underscore, what's it called? I think it's Marvel public API key. Yeah, let's see where the key is. Let's go to the plist, just open it. Oh, yeah, of course. There we go. So we're gonna take this public key, copy it, enter it here, value, and it's fine to not have it a secret because it's public, but we're now gonna also add the private key, and that one I do want a secret. So you see that it automatically obfuscates it. Here we have the key, paste it in here, and save it. And now we have these to fetch from the server or from the build environment. So back to our script, and I've prepared a little code snippet for that. There we go. Just add it here, and it uses plist body actually here to clear the dictionary, then add these public string and a private string to the dictionary, and this is then the location of the dictionary. So let's do that. Let's commit this to and see if it works. So commit. Yeah. Okay. Commit it. Then let's push it as well. Push it to master. And then we see another build kickoff, I suppose. Yep, there it is. Build 2. It's gonna do the same process again. And hopefully it will build now, right?
Are you using credentials from the plist or from the environment?
I'm writing the credentials from the environment variable into a plist. Yep.
How secret are those secret environment variables?
Well, obviously not very secret, right? So yeah, I'm gonna change them afterwards because it's also.
Is it just hiding it in the UI, or is it storing it somehow? It's not.
Yeah, currently this is just a simple project, right? So this one is included in the app bundle as well. So it's not.
You said as an environment variable, they stored in the workflow.
Yeah, they're stored on the cloud. Yep. So let's go back to a build. Oh, it still failed. Why is that? Let's see the logs again. There's still this build phase script. Let's see above what it did. Another one. Oh yeah, here is my pre-built script. It should have run probably. It's not executable, but it's yeah. Xcode gives a warning, but yeah, I'm curious why it didn't work. It worked before. But anyway, yeah, this is the way you would probably do something like this, just using a build script like that. CI pre Xcode build, yeah, looks fine.
Do they all have predefined names?
Oh wait, I didn't commit it, I think. No, I didn't commit it. What? Just force push. Yep, don't try this at home, guys.
Why didn't it commit? Why are you doing it via Xcode?
Yeah, I don't know exactly. Maybe I didn't stage it or something. Yeah, I'm not sure. I usually go this route. It's much easier.
It even triggered a build, so it's weird.
Yep. So let's try again. Build 3. You can also probably check the logs already to see what it's going through. This is still loading, but you see, yeah, it runs Xcode build.
There's no live logs? Just like Bitrise?
There should be, yeah. There should be. Normally, you could. Let's go back and also show you right now. There's a new tab here, Xcode Cloud. Oh, this is Hilversum. Wait. Let's go here. If it works.
So for the most part, you don't need to go actually on in the browser. Most things are just in Xcode itself.
Yeah, pretty much. Yeah. If it works, yeah. If it, yeah, I have to log in again, of course. Let's do that. This is Hilversum. Back to my private. And then here's the app, right? And then here's the tab again. And you see here the workflows, the builds that I've started. And you see actually now that the build is succeeded. So hooray. Yep, nice.
It has 3 warnings?
It has 3 warnings. Yeah, of course. Yeah, I'm not sure what they are. Probably we can inspect them as well. Yeah, here we go. So I'm using an unsafe way to make an MD5, and the MD5 is already deprecated for a while. So yeah, but yeah, for some reason the Marvel API still works with MD5. I'm not sure why, but let's try one more step. So we did this, right, and we got it to build, and the next step on my project is actually I would like to utilize SwiftLint for, and I therefore first have to of course add it to my project, and it's very easy to do it. I already have it installed, so just through brew, brew install SwiftLint, and then you have to add a configuration. I think there's already one in place. Add a new build phase script. And I already prepared the code to do it. This is the part, and remember that now you also have to export the path if you're ARM64, so M2 or M1. Otherwise, yeah, it just won't run. Let's see if everything is set up. I think I have to disable the sandbox as well. I have it disabled, looks like. So let's run it, see if it does anything. Well, it looks like it. Yep, I have like 20 warnings here, 22. So that's nice. Let's disable these 2. So I can type SwiftLint, disable, next, and then the identifier name. And I do the same for the other one, because SwiftLint doesn't like underscores. So now if I build it again, it runs. So that's cool. I have some warnings, and I want to show them in Xcode Cloud as well, because yeah, I want to show them in my PR as well eventually. So what we have to do is very simple. We just have to install SwiftLint on Xcode Cloud. And how do we do that? Well, we again create a new build script. Remember that I told you that post clone is for installing new tools, so we're going to do that. Add a new CI post clone as a, and then we just have to call brew install. I think I have this one. Yep. We'll do it the neat way, so this way. And then of course commit it again. Let's see if that works. Push it. I won't force it this time. Then of course a new build starts. Wait on that. There we go, build 4.
Is there a reason why it only shows the last 3? The limit?
Yeah, I suppose. Yeah, I'm not sure about actually. I just just noticed it myself. Yeah. So here we go. New build environment. It's gonna spin up a new environment, and then hopefully install SwiftLint and do some magic. So here it runs the post clone script. Let's see if App Store Connect actually shows live logs. Here we can see the builds as well. Just click on the 4th one. Then we can click here and check the logs. And here we see also a breakdown of what it's doing. So here you see that we have installed SwiftLint. Here it's downloading it. And yeah, it says, well, I'm ready for it. So it now runs the Xcode build. We have to wait for it a bit. Gonna all the way boil down to every step it's gonna take. Yep, this is pretty much live. Yep. And then it's done. It's saved. So let's see what it did. Yeah. Here it already shows that there are 27 warnings now instead of 3. So I suppose it worked, right? Let's see. View the logs. Oh yeah. Yeah, it does. Yeah, because the script is not CH modded. You should do that. I didn't, but yeah, just wait till it's completely finished, I suppose. It's still saving some artifacts for some reason. Maybe just refresh. Yep, so there we go. Build succeeded. And here are all the warnings that we just saw in Xcode. So that pretty much concludes my demo as well. Yeah, this is what we wanted to see. And these will get posted to your PR request as well. So you get little boxes in GitHub, for example, saying, hey, you have a to-do that should be resolved or anything. So that, it eases up code review this way. So back to my presentation. This was the demo. I have to set screen sharing again. Stop mirroring. Yep, so we did the demo. Let's do a recap of what you just did. We added an app to the cloud. We've defined a basic workflow, and then we used environment variables to define the credentials and to add them through the pre-built script. And then we installed SwiftLint on Xcode Cloud with a post-clone script. Very cool, right? So, of course, these are the basic stuff. And we went a lot further with our Yogsnell app. I'm gonna tell you a bit about that as well. So the YOSHNL app, we started rebuilding it, I think in April or May. All the way from the ground up, minimum iOS version 15 and all Swift UI. We use SPM for feature modules. We use Kotlin multi-platform as well to share code with our Android app that's also being rebuilt completely. Of course, we also want to do some snapshot testing. We use the one from, what's it called? Pond3, thank you. And of course, we want to do Xcode Cloud as well. So here's the old app. It's just a linear list down with a bit of playful tiling. You can watch previous shows. There are some polls here that kids can fill in, and there's of course the article itself that if you click on it, then you can read the whole thing. And this is the new one. It's much more playful. Instead of a vertical scrolling list, we now have a horizontal scrolling list, and each page is actually a news item and with some interaction. And we can decide on which interaction it is. We have a poll here, and that's the first one. Then, for example, a video, just an image, right? It's also possible. This is the nicest tree in the Netherlands, apparently. We also have a quiz. So, yeah, we can ask kids, hey, how long is a marathon? And yeah, then the kids can guess which one it is, and it will show them which answer was right or wrong. Play a little animation just to make it interactive. And of course, we did not want to lose the informative value, so you can also click on read more. That's down to just read the article. And what we also added is responses from the kids. These are curated by our newsroom, and kids can just reply to for example, to the 3 article and say, oh, well, this is really cool. And kids do that a lot, actually. Sometimes we have around 8,000 reactions for one poll or article. So it's very cool. So I've told you a bit about our Xcode Cloud setup. We actually have 5 workflows for our YOSHNL app. One for pull requests. So yeah, I showed you earlier. We just have a trigger that works on the pull request. And then we have 4 for our release flows. One for internal test flight builds that only goes to us. One for externals that also go to the newsroom, for example. And both are either with test or release configurations. So we can say in our control with our workflow which of these configurations the app should connect to. So of course we also have SwiftLint and authentication. Then we also have the what to test file. And the what to test file is a file in your project, and you can enter test notes for the user that tests the app when it goes through test flight. And I will show you a little bit later how that works. Of course, Kotlin multi-platform, that's an issue because suddenly we have to compile Kotlin on our Xcode cloud platform. How does that work? You know, and snapshot testing is trickier than it sounds because, yeah, you might run an M1 and Xcode Cloud runs actually on Intel. So you get rendering issues, right? How do you deal with that? Then some private frameworks we have. I already said we have around 15. And how does that work? How do we get those on Xcode Cloud? And finally, we have Sentry, and we use Sentry for crash reports. So first, SwiftLint, I already showed you this. So just, yeah, add a post clone, brew install SwiftLint, and then you're done. And then what to test. And what to test lives in a folder similarly like CI build scripts, but just in a different one. It's you have to add it in test flight in your root, and there you can add test notes, and of course you can also automate what you put there. by using a build script, for example. And this is a build script I wrote that fetches the environment API environment, and then annotates for the user, that the test user, which environment he's actually looking at. So just for convenience, so that our product owner or people on the news floor know, hey, this is a test environment. I should take care, or this is a production environment. Danger. So it works very easy. Just I create a file, then write a message to it, and that's it basically. Put it in the right folder, and the Xcode Cloud will automatically pick it up and put it into the test notes at the test flight step. So it's very cool. And I also saw, for example, Apple had a talk about this as well, and they actually loaded Git messages and filtered those for useful change logs. So that's another road you could go in through with this. So then Kotlin multi-platform. Kotlin multi-platform. We have a module that is shared with Android. It contains all our use cases, our networking models for each of these screens we just saw. So if you want to fetch comments, the app is going to ask the multi-platform part to fetch comments. Then it will return, does the networking behind the scenes, and then go back to, and the response comes back into our Swift code. There's various options to add to your project. You can just make a single project, like in the tutorial that contains both apps, the Android and the iOS app, and the module in the same folder structure. But we didn't like that as much, so we went for different Git repositories for each of these. So, and then we embedded the common module as a submodule. So we built this Kotlin multi-platform thing with a build script. Just call a Gradle thing that's called embed and sign Apple framework for Xcode, and it will compile the Kotlin code into Objective-C code into a framework. And well, how would this work in Xcode Cloud, right? Well, because if we run this post or this script, this build phase script, it will fail on Xcode Cloud immediately. It says, hey, you don't have a Java home. So too bad. So how do we actually get it? And naively, you would say, well, just do brew install Java and then you're done, right? But unfortunately, it doesn't work that way, because you also have to symlink stuff to Java home and stuff like that. And you just don't have access to it. Why is that? Well, each of these temporary environments that Xcode Cloud creates is in a sandbox, so you can't actually touch stuff that is not that is in your what's it called? I'm not sure exactly. Just in the root library stuff. So we were getting stuck there, and we thought, well, what should we do here? We don't have access to the install directory to symlink it to Java home. So we decided, well, let's just download the tar from Oracle with the JDK, with just a simple curl command, unpack it in the folder in the project, and then we added the Java home to our environment variables. It's a bit hacky, but it actually works. And Xcode actually picked up on this. Let's Gradle compile our module and then compile our project with that module. It's very cool. So it's nice. Yeah.
Brew was pre-installed, or
Brew is pre-installed. Yeah.
Apple is actually.
Yeah, exactly. Yeah, and also they have support for CocoaPods, for example, out of the box, and that kind of thing. And
Command is pre-installed. Is the pod command pre-installed?
yeah, I think so. Yeah,
Wow.
yeah, because So can you? Yeah, you can just use that out of the box. I was surprised actually that they didn't have a Java environment set up for you as well. But maybe it will come later.
Install Gradle through Brew.
Oh, that's a good question. I haven't tried that one. No, it's nice. But let me continue because we're a bit out of time already. We also did some snapshot tests, and like I said, there are some problems with that, right? Because they need to run on the same environment to match the screenshots, and maybe also on the same device. So if you have if you record it on an Xcode or iPhone 14 on locally, you also would ideally want to run the tests on Xcode Cloud on the same thing, on the same iPhone. Luckily, that's possible, but yeah, you have to be really careful with that. But yeah, so there's also a solution to cover for the difference between Intel and M1. Just put the perpetual precision on the library to a little less than 100%, and it will go as planned. We use 0.98, and that will cover most of it, I think, if not all. But the problem we had actually was that our recordings were not found at all during testing. Why is that? Well, yeah, they just weren't included. So I have to go back to how Xcode or how the build process works. When Xcode Cloud builds, they produce actually some artifacts, and they pass those artifacts into the test phase of or the test command, not directly, like you're used to in Xcode itself. And yeah, the snapshots, yeah, they live in the code base, right? And not in those artifacts. They weren't copied along. So we thought, how could we yeah, get those snapshots through the tests? And one thing we found out was that the CI scripts folder, yeah, that folder was persisted across those actions. So we kind of mistreated that. We created symlinks to snapshot directory, and we adjusted snapshot testing code as well, because it looks into a certain folder, and we had to let it point to a different one. The one actually that yeah, that we symlinked, and then it's we got it to work. But yeah, I think we spent yeah, a few weeks before we figured it out actually. There's even a better solution. You can actually create a test bundle on compile. Copy all the screenshots that you already have recorded into that bundle, and then pass that bundle to the test phase, so the test command. And it's actually yeah, shown here in the blog that I posted. I won't go into detail more than I have now because of time. But check it out. It's very nice, nice trick. Actually, the writer of this blog asked Apple, "Hey, I'm using the CI scripts folder now. How could I do this better?" And yeah, at WDC in the Slack thing, they had this since this year, and yeah, they actually proposed, well, you can use test bundles for this. So 2 more slides I have. One is about frameworks. You can build frameworks here. Here's an overview of all the frameworks we have in our apps. And yeah, you can just add these in a similar way as you would do with an app. The only thing that's still missing is that SPM packages as such. So if you only have an SPM package and you want to bring that to Xcode Cloud, it won't work. Not sure why, because Bitrise, for example, does support that already. But yeah, you have to wrap it into a project and then commit that project to Xcode Cloud, and then it will work. And a final note here is, yeah, adding a dependency requires you to give Xcode Cloud access to the repo. So first time it will fail. Then it says, hey, you don't have to have this repo authorized. Would you like to authorize it? It gives a nice, yeah, what do you call it? notice, and then you can just say, okay, I want to approve, and it will fix everything for you. Not sure, actually. Maybe. Okay, and finally we use Sentry. Yeah, exactly. Finally, we use Sentry for crash reporting. So we have a post-build script that installs the Sentry CLI and uploads it to Sentry if the build is actually completed, and of course also if it's going to test flight. So not for our PR builds, we skip that. Then we check for it which workflow it is. And if it's a release workflow, then we say, okay, let's also upload these sims to Sentry. So to recap, finally, utilize build scripts. Build scripts are really awesome. They're really the powerhouse to Xcode Cloud. They unlock all the features that other platforms also have. Installing on, we've seen installing SwiftLint on Xcode Cloud allows warnings to be part of the test report. So it can be part of the report in your PR, etc. We've seen how to use the what to test file to automatically notify your testers about what to test. And then, it's possible to actually install Java on Xcode Cloud. And you have to keep in mind there that the environment is sandboxed. There are actually a lot of caveats with sandbox testing, so be aware of that. And Xcode Cloud actually supports the building of Xcode frameworks as well. So, I think really cool. And this pretty much concludes my presentation. So thank you. Questions?
Is there anything you could do on Bitrise that you cannot do on Xcode Cloud? Like, if only we could do that.
No. We could do anything. So no. But our setup on Bitrise was also pretty straightforward. So we actually do more now, I think, than we did on Bitrise even. Yeah.
How do you debug the scripts? Is it a matter of just firing off builds and failing over and over, or is there something?
Yeah, pretty much. Yeah. Yep. I haven't found a way to make that easier. No.
Is it just still like available for everyone, or do you need like the 90 euro developer fee? Was that included in the price?
No, it's a separate number. So you have to have the developer subscription, and then you have to subscribe separately to Xcode Cloud. Yep. Yeah, exactly. Yep, and it will prompt you for it automatically. Yeah.
So probably I know the answer, but still, how you told your managers that you have to migrate one time to Bitrise and then come back to the new environment, because it still takes some
Yeah, exactly. Yeah.
decisions.
Well, the first time we didn't have really a choice, right? Because Bodybuild actually ceased to exist, and we still wanted to use an environment. So we had to. And then later, we just used the cost argument, right? Going from 3,000 euros a year to 600 was a really big factor. Yeah. Yep.
Can you build and release more than one target in one workflow? Like, if you have multiple schemes, multiple targets in your project, can you, in one job, deploy them all?
Yeah, that's a good question. You can actually build more than one target, but I'm not sure if you also can release more than one target with a post script. No, I don't know if that's possible. No, I haven't tried it.
So you mentioned that you can only run it on Intel machines at the moment. That's quite a big deal. So there's no configuration where you can choose to run on an M1 or M2 at the moment.
No, they all run on Intel. If you So I'm not sure why that is. It's probably ease from Apple. They had to scale probably. Yeah. So I'm not sure. Yeah, but it's not available yet.
That's how
Yeah.
Or did they make it available on AWS or something privately?
Oh, yeah. I'm not sure. No, I don't think so.
Can you choose the Xcode version?
Yep, definitely. And also, actually, also the macOS version. So it's it's similar to Bitrise, I think.
How granular is the access to edit workflows and view builds between different levels of team lead and individual?
That's a good question as well. I know you have a checkbox that says I can only edit if you are admin or something. So there's some granularity in it, but yeah, just either you're an admin or and then you have access, or everybody has access. Even developers or that kind of role. Yeah. So, yeah, one more.
Actually, I have 2 questions.
Of course.
Is it possible to manually trigger a workflow to start it and include an environment variable with that?
Well, I suppose you could, because you can also disable a workflow and then start it manually. And then you probably would have to add the environment variable first, but not, I think, on the, maybe with an API and connection, maybe like that or something. But yeah, not sure.
It's one of the things we use from GitLab. You can run a GitLab runner with a temporary environment variable.
Ah,
You use it
yeah.
to change environments between the apps.
Ah, yeah, interesting. Nice. Yep.
And the other one was, can you include the simulator builds within an artifact? Basically, what you build and what you run as a test on the simulator, include it with an artifact. So, for example, a designer can download it, drag it onto the simulator, and just check out the app.
Ooh, yeah, not sure. I don't know. I don't know if it's possible. Yeah, I don't know. No. Yeah, you can archive and you can do stuff with that, but
It's available on Brew, so you can switch between targets and environments, and also you can assign the data to environmental variables for each target.
Okay, what was it called?
Variants.
all right. Well, thanks, guys.
Cause I know you are my destiny. Even you're down or high, I'll be with you, only with you. Even you're down or high, I'll be with you, only with you.
Yeah. Good evening, everybody. It's been a while since I was at CocoaHeads. I think the last time I was at a CocoaHeads would have been June, probably, for WWDC. And the last time I presented, it's been a while. So when Marco asked me on Monday, would you be able to come join us for a presentation? I said, yes, Marco. I think I can do that. And then I did, and he's like, what's going to be your topic? And we talked about that a little bit. And then he published my presentation title, and he said it's going to be Concurrency of SwiftData. So, okay, maybe we should call this a story of miscommunication. Just to prove that, in Dutch, I said to him, I don't know what I'm going to talk about. It's going to be concurrency or SwiftData. He said, let's do that, concurrency or SwiftData. So yesterday I looked at the schedule, concurrency of SwiftData. It's like, okay, well, I guess I'm on the hook for that one. I know concurrency, I know SwiftData, I know all of these topics, so let's go for it. Concurrency of SwiftData, exploring SwiftData's concurrency APIs. So I wrote this talk this morning, because like I said, I had no idea what I was going to talk about. It's going to be either concurrency or SwiftData, but we can do both. It'll be fun. So before we get into concurrency and SwiftData, let's actually talk a little bit about SwiftData itself, because it's a core data wrapper, right? And that's not the same way that SwiftUI wraps UIKit, because Apple kind of hides that from us. They're like, yeah, it uses UIKit under the hood, but we reserve the right to rip that out at any point in time. For SwiftData, Apple actually says you can rely on the tried and tested powers of core data, right? So we can actually say SwiftData is for sure built on top of core data, and it was meant to be that way. And that kind of means that when we talk about SwiftData's model container object, we really mean an as persistent container. When we talk about a model context, we actually know that there's a backing and as managed object context. Model objects, they're NS managed objects, right? Of course, I can't prove the extent of how big or thin the wrapper is, but we know that they're under the hood, which means that we know a lot about how they're supposed to work. What's also fun is that a lot of our debugging still works, so that's great. We don't have to reinvent the wheel there. And of course, the best part, it also means that we're bound by the same threading rules we had in core data. They did not change that, they did not remove that, but they did do a little bit of a better job of hiding that. But more on that later. So if you don't know what model container, model context, model object are, that's not a big deal. We'll actually look at how we make a SwiftData model. A SwiftData model is a class. I know that a lot of people, when they talked about SwiftData 2-3 years ago, said, I hope it's going to be structs. It's not, it's classes. Why? Because NS managed objects are also classes. Simple. All we have to do to make something a SwiftData model object is apply the model macro to it. And that adds a whole lot of boilerplate code that I'm not going to expand here. If you really want to copy this code, go to Xcode, do expand macro, you'll see what it generates. It's more macros, it's a whole lot of stuff. It's really not that interesting. Also notice that I have this optional date here. If you've defined managed objects before, you know that almost everything was optional, simply because you wouldn't pass these arguments as initializer arguments, so Swift wanted them optional. They don't have to be. This one is actually optional because I wanted it to be optional, not because of some core data limitation. So that's nice. Next to models, we have our model container. The model container is similar to NS persistent container. It's basically your entry point, your main point of creating everything for your SwiftData container, right? So similar to core data. We can make one by calling the model container initializer and passing it the model classes that we want to use. In this case, it's just one. If there's multiple, it uses variadic generics, so you can just pass as many arguments as you want instead of an array of models, which is kind of cool. So if we've added our container to our view, which is typically how we use SwiftData, by the way. SwiftData, SwiftUI, they're best buddies. If you want to use SwiftData outside of SwiftUI, not best buddies. Okay, so if we have a view, we can grab a model context out of the environment. Again, it's very similar to core data. And here's the cool part. If we want to insert a model object into our store, we can make an instance of it, pass the arguments that we want to initialize this object with, which is kind of nice. However, just like before, we still have to associate our model objects with a context. If they're not part of a context, they will not be persisted. They will sort of be floating out there in space, not linked to anything. So in order for them to actually be persisted, we have to add them to our model context. And this is all we have to do. This is actually kind of nice. SwiftData models or model contexts can autosave. So after we've inserted something into a model context, shortly after we did that, it will automatically save and persist to your store. This might not be what you want. You can opt out of it. But if it is what you want, it's really kind of neat. You might even say it's amazing. But sorry. Usually by the end of the function scope-ish, but it also works with certain view lifecycle events and all that stuff. So Apple doesn't tell you when, but it's quick. All right, so this example that I just showed you is, of course, very, very simple. I just made an object, inserted it, and I'm telling you it's amazing. Like, really, come on. Surely the bar for amazing is higher than that. And if we actually think about a typical iOS app or a typical app in general, we'll see that CRUD is a common pattern. If you're not familiar with it, it means create, inserting new data, read, fetching data from your store, update, modifying existing data, or delete, deleting existing data. Right? And if you think about pretty much any app that uses persistence in core data or SwiftData or Realm or whatever you like, these are probably 4 operations that you find very interesting. So if you want to implement this pattern in a core data app, right, kind of rewinding back to core data so we can better understand SwiftData, what I really love to do is have a single page for both creating and updating a model. I know that some people will have 2 SwiftUI views, one for create, one for edit. The create one inserts a new object, the other one updates an existing object. I like to have them both as a single view that I can just pass an object to and say, well, this one's new, this one's updating, but you don't know. You just know that you have a model object. Because actually, if you didn't know, managed objects are observable, which means that we can bind SwiftUI views to properties. So we can bind a text field directly to the title of a managed object. It's kind of neat. And to make this work beautifully, I like to use child contexts as a scratchpad. And this is kind of important because this, to me, is one of the things where I'm like, if SwiftUI can do this well, or SwiftData can do this well, it is truly amazing. But simply me saying that is kind of a spoiler. I won't say more than that for now. So what I like to do is if a user is editing a managed object and they decide, well, I made some changes, but I want to discard that, I just discard the entire context, which means that the entire set of changes is gone. For a new object, similarly, I added the new object to a child context. If I discard that, the new object is simply gone. If I persist, I'll actually save that into the view context, and now we have it everywhere. If you have trouble visualizing that, here's more or less what it could look like. In the middle, we have a managed object context, which would be used by SwiftUI view. So it drives a fetch request in core data and then populates a SwiftUI list. I also have a child context to which I can add new objects. And if that child context goes away, that new album also goes away. Similarly, if this was an existing one, changes to it would go away. Because all model objects, if you have one in a child context, you can have one in a list as well, right? So the view context can have an instance of, let's say, holy hell, and the child context can have its own version of that managed object, and it can change that in isolation. Even though it's classes, they're both separate instances that just happen to be created using the same underlying data. So knowing this, that I like child contexts, we can create them in core data. If you thought this would be complicated, it's really not. All we need to do to create a child context is this. Make a new instance of NS managed object context and give it a parent. In my case, it would be the view context, which is used for my SwiftUI views. And this will associate that context with the view context, the underlying store, and everything else. So we don't need to do anything special in core data to have a child context. It's really as simple as creating an instance and giving it a parent. So in SwiftData, however, we don't have this. Apple simply decided that child contexts and SwiftData are not going to be best buddies. We don't need them. We're not going to get them yet. Maybe next year, I hope. But for now, that's sort of where that story ends. So for doing CRUD in SwiftData, you're still going to have to do some workarounds and have your fields separate from your entities and all that. Not fun, Also not concurrency. So let's move on to doing work in the background. If we want to do core data work in the background, we also need to have a separate managed object context that we can create as follows. Still 2 lines of code, so that's also pretty straightforward. We can simply ask an NS persistent container for a new background managed object context. And again, this is just so you know where we're coming from. What are we wrapping with SwiftData, and how does SwiftData do this? So if we perform core data work in the background, why would we create that separate managed object context? Well, first of all, if we want to have an operation that runs off of the main thread and interact with core data, we have to have a managed object context that is compatible with this. If we use the view context, we must interact with core data on the main thread, because that's what the view context is hard linked to. It allows us to work with a managed object context without impacting UI. Imagine you're adding items one by one, you're generating them or whatever you're doing. It takes a while, so you're going to add maybe 100,000 records. You don't want your view to update every time you insert a new record. So having a background context is beautiful for this. You can do your work in the background, insert items, all of them, and at some point you're going to call save, and that's when your UI updates. Sadly, what it does not allow us to do, and something that I have seen people try in SwiftData, which was almost the reason that I actually just decided to roll with Marco's suggestive name for my talk. Some people want to fetch stuff in the background so that the fetch is not blocking, and then put all your objects on the UI. That's not what a background managed object context is for. Right? If we use a background managed object context, we're going to get objects that are tied to the background as well. We can't use them on the main thread. It's core data's threading model that we cannot break. It also doesn't allow us to update the database without impacting the UI at all. And what I mean by that is once we save our managed object context in the background, the view context is actually going to have to actively absorb what we just added, which still takes time. Right? So it's not possible to do that in a completely non-blocking way where the view context will just magically asynchronously get updates. We have to still do that on the main thread. So that's sort of background on backgrounding with core data. And if we think about core data context and threading, what's really important to know is that a managed object context can either run code on the main thread or on a private queue, where the private queue is managed by core data. We don't own it. We don't interact with it directly. This one's big. Managed objects are not thread safe. So keep that one in mind. We're going to talk about that a lot more in a bit. You must run core data code on the correct queue using perform or perform and wait. So if you want to use your background managed object context in the background, you're going to have to call perform on it to make sure that you're running on the correct queue. This is the worst. There's no compile time help. If you mess this up completely, the compiler will not tell you, hey, maybe you shouldn't be doing this on that queue, even when you're doing dispatch queue main and then interacting with your background managed objects. However, we can pass arguments to our schema for debugging. So we can tell our Xcode schema that, or our app schema, that we have to debug our code so that core data crashes whenever it detects a problem. By default, it will just happily chug along until it figures out that it couldn't, and then it will crash and it will look very weird. And if you're lucky, you'll get all that's left to us as honor as your crash message. So if we want to dispatch to the correct queue, we have to write code like this. Right, so this is a background managed object context, and we fetch a bunch of objects, we interact with them, we do work with them, which is fine. The top part is fine. And the bottom part would be a problem, right? Because we're dispatching to main and then we're using our background context. This would cause issues because we're not on the correct queue for this context. So back to SwiftData, because the rules have not changed. Right, we still have to be on the correct queue. The view context from SwiftData still has to be used on the main queue and all of that. So let's look at some Swift UI, concurrency, and SwiftData code. Who here thinks that this code should probably be fine? Nobody. One person? Right, well, if you already all know this, why don't you tell me? No, I'm kidding. This should cause problems indeed, because we're using a detached task, which means that we're going to be very explicitly not inheriting any main actorness. So we're going to be in the background and we're going to be making a sample model object. That on its own is fine, right? We're making the instance. We're not interacting with any contexts. and then we await model context.insert object. This should kind of be a problem because our model context belongs to the view, which means that it's main actor bound. For some reason, it doesn't crash, even when I enable concurrency debugging in core data. So SwiftData does something here. It very helpfully gives us a compile time warning. So it tells us you shouldn't be doing this, where I'm like, please make this an error if I shouldn't be doing this. But all of the sendable stuff with concurrency, in my opinion, could use a few more errors rather than warnings. So this could cause problems. It's actually telling us it's not safe because non-sendable type model context and implicitly asynchronous access to main actor isolated property model context cannot cross actor boundary. So in normal-ish English, that means that model context is not safe to be passed around between different threads, tasks, or actors. And since we were on the main actor before, and now we're very much not on the main actor, we shouldn't be grabbing model context from the main actor and pulling it in here. But the code doesn't crash necessarily. So what does this tell us, though, if we look at this? The model context is not sendable. In other words, we can't just pass it around across thread boundaries and task boundaries and expect it to work well. And this matches with core data's threading rules. So if we look at just that one warning, can we make that worse? Of course we can. Because we can also define our object outside of the task. So we are making our object on the main actor, and then we're going off of the main actor to add it into a model context that belongs to the main actor. And that gives us an error saying capture of object with non-sendable type sample model in a sendable closure. In other words, our object is not safe to be passed across concurrency boundaries. So model objects are not sendable, which is also the same as core data. So hopefully, with concurrency debugging enabled, this should crash our app. But again, it doesn't. Can this cause problems, though? Almost certainly, yes. But probably after you've ran your Xcode cloud builds and shipped this off to production and had this out there for a while, and then on a Sunday, you're going to get everybody crashing at the same time for this reason. I don't know why these kinds of crashes act like that. So can we catch this with a launch argument or something similar like we can with core data? For some reason, no. I don't know why SwiftData somehow manages to abstract this to just the level where I think is more dangerous even than what core data does by default, because we can no longer catch this problem. Also, I really wish that these warnings were compile time errors, because clearly this is telling me, hey, you are opening yourself up to data races right now, which are notoriously hard to reproduce, do on purpose, debug, and all that. But, you know, the compiler is just telling me about it. I hope in Swift 6 is going to be more of errors. But yeah, for now it's not. So at this point, we know that SwiftData leverages modern concurrency APIs. Otherwise, it wouldn't be complaining about sendable so much. But if we have that, how can we skip a little bit and do some work in the background? Because what we just saw was in a view, and I detached the task, and I was like, this should be on the main actor, but it's not, and it's not causing problems. But what if we actually wanted to go to the background and perform a whole bunch of work? I will start by making a background model context. I wish it looked like that. It doesn't. It's way more complicated. We have to write our own actor. And this actor is a model actor. And I'm pretty sure in beta 1, they didn't have the fancy model actor macro. They do now. So that's kind of nice because it saves us a lot of code. But that actor that we create here will act as our queue, essentially. So if we enhance that code snippet a little bit and expand the macro, because this one I think was a little bit interesting, here's kind of what it looks like. So at the top, we still have the function makeNewItem that inserts a new object into my model context. Then we have a non-isolated model executor, a non-isolated model container, and we have an initializer model container that takes a model container. And that then creates a model context, a model executor, and it assigns the model container to itself. There's also a computed or sort of protocol extension defined model context that we can access. So that's what I'm accessing right up top there in the model context.save. It's just a default property that I was given by the protocol. We don't see it here. So this would allow me to take this to the background and start running my make new item in the background. But let's talk about why this is an actor in the first place. Why do I have to create an actor myself to do work in the background? Why can't I make a context that I just call perform on? Well, first of all, calling perform on a context, that's very much core data style, right? We want to have this actor because that's what modern concurrency looked like. Because the model actor will internally synchronize all of its function calls and all access to model containers, model context, and everything into an executor. And an executor in an actor makes sure that all jobs that the actor is given, so all function calls, all property access, all of that, is run on the correct queue. It's how the main actor makes sure that everything we do on main is actually running on main. The executor is simply dispatching to the main thread every time. For SwiftData, the executor will dispatch to an appropriate queue, similar to how managedObjectContext.perform dispatches to an appropriate queue. So this actor essentially becomes an abstraction around perform and wait, and it gives us a compile time constraint, which is good, because now if we do things wrong, it's actually going to say you can't interact with this actor in this specific way, and that's actually an error. So how the model actor creates this executor, it's like this. There's a default serial model executor that SwiftData comes with. And what it really does is like a serial queue that will execute instructions one by one. So to use our custom actor, we maybe would like to try something like this, where we create our custom actor in our application and we make a custom model actor and we pass it a model container for our models, and then we say model context custom actor.model context, because a view needs a context. Luckily or unfortunately, depending on what you're trying to do, we cannot do this because the model context is isolated to this actor. So we would have to await this call in a task, which of course we cannot do in this body because the body is not async. So we can't just inject it. The container itself, as we just saw in the actor, would be non-isolated. But if we inject that, our view would actually take the model container's default model context, which would be main actor bound. So that would not work for us. The context is isolated, so we can't grab it in our view. And also it's not sendable. So even if we could somehow inject this into our view, we really shouldn't, because it belongs to the actor. So we should only interact with it inside of that actor and not make it past concurrency boundaries. In other words, we can't take it out of the actor onto a different task or different queue. So what we can actually do is we can create our actor on demand. So we can say let actor equals custom model actor inside of a button action. It's pretty lightweight to make this actor, and it's pretty lightweight to grab the model context container. So that's nice. And then we can make a task and we say await actor make new item. And that works. This compiles, this runs. And here's the real big question. Did that actually do something in the background? No, it did not. How about now? Does this do something in the background? Because now we're detaching to call actor.make new item. Well, let's add a breakpoint and make new item and find out. No, we're still on the main thread. As you can see right up top there, thread number 1, custom model actor make new item. So this is not what we wanted. We just defined a custom actor. We used it. We did a bunch of weird things like making the actor inside of a button action, but it still doesn't work. So what's really happening here? We're not calling make new item from the main actor. We've used task.detached. So clearly it doesn't matter if we call from the main actor or not. Make new item is going to run on main anyway. We haven't annotated make new item with main actor, nor did we annotate it with non-isolated. Maybe those could have impacted this, but they're not there, so that's fine. We did not explicitly tie our actor's executor to the main actor. So the culprit, we created our actor from the main queue. So apparently a model actor's default executor will latch onto whatever context it was created in. So if we make our actor on the main thread, it's going to make its serial executor and say, oh, we're on main now. So probably you want to be on main all the time. So if we try this again, if we actually move that little bit of code down to make the custom model actor inside of our detached task, now all of a sudden we hit the breakpoint and we are in fact in the background, thread 5 in this case. right? So we can see that it matters where we make this actor. And luckily, making them is pretty lightweight. So in this case, if I want to do work on the background, I'm just going to make the actor right before I want to do the work. I'm going to call the functions on the actor that I have to call, and the work will be done in the background. Victory. So can we create a model object in the actor and then return it? That would be really cool, right? If we could just make the object in the background, return it, use it in our view. Sadly, not really. This code will compile just fine. There's no problem with this. We make our new model and we return it. However, when we try to do this, we're back in sendability hell. Because we're going to get some warnings saying non-sendable type sample model returned by call to actor isolated function cannot cross actor boundary. Right, so we shouldn't be doing that. And again, I really wish this was an error because it's clearly telling me what you're doing is dangerous. You're going to run into data races. It's going to be hard to debug, but it's just warning me. So with a custom actor, what can and what can't we do? First of all, it does not replace a child context, right? A child context in SwiftData does not exist. It can create background contexts, essentially, or sibling contexts, but never child contexts. It does replace a background context because we can run code off of the main thread, so that's nice. We cannot use our actor to populate a view, which, if you've done a lot with core data, makes total sense. But I've seen a couple people coming into SwiftData already thinking that all database operations should be in the background. So they are somewhat confused by this because these are warnings, not errors. So what's going on there? So we shouldn't, because the sendability warning is pretty clear. So that also means we can't use this actor as a repository. You might want to have something sitting in front of your database where you call functions, it returns results. We shouldn't be using our actor that way. So model actors should be completely self-contained in terms of the work that they do, right? So if you want to build like something that synchronizes your local Swift data store with a remote backend endpoint, your actor should receive your networking layer, make the API calls, insert your data, etc., etc. Or you can pass it the data you want to insert, whichever you would prefer. So in summary, SwiftData wraps core data, so it follows many of the same rules. Most of the things that I found out with concurrency and SwiftData that I showed you in these slides, it's all based on me knowing core data and me knowing Swift concurrency, going through the warnings, going through what's happening, observing what happens, and simply saying, oh, wait a second, this makes total sense because it works like that in core data. SwiftData just abstracted it good or poorly or very thinly, but there is an abstraction there. Model objects are not sendable, but the compiler only warns about that. So core data concurrency or SwiftData concurrency or core data concurrency debugging doesn't see these violations. Normally, if you do this wrong, your app will crash with a nice message, which is great. Somehow SwiftData works around this, which feels more dangerous to me because sendability warnings are telling me this is dangerous, but we no longer have a tool to make this more explicit. There's no wrapper for child context in SwiftData. If you really want it, by the way, there's still core data under the hood, right? So you could still grab managed object context and do a bunch of work. We have to make a custom model actor to have background contexts. Luckily, we have a macro for it, so that makes it relatively easy to do. We have to initialize our actor in the background to actually make it work in the background. That's a bit of a gotcha. If you do that wrong by accident, you're going to be running on main anyway. And apparently SwiftData relies heavily on sendability and actor isolation, and I think / hope that Swift 6 is going to give us a lot more errors rather than very subtle warnings. So thank you. Thank you, Marco, for giving me an amazing talk title to work from. If you like this talk, you want to learn more about concurrency, core data, or combine, and probably in the future SwiftData, I have a whole bundle with these books. Go check that out. And yeah. Back to the thank you slide. And of course, if we have questions, I'll happily take them. Yes?
I haven't really looked into SwiftData, but does SwiftData need merging? For example, can I just make a detached task, make the actor, insert the item in there, and then pass along the ID from the actor, basically?
Mm-hmm.
Just immediately fetch it from the model context of that view.
Mm-hmm.
After that task. Is that possible, or is there still merging going on with the sibling context actors?
Yeah. So the question is, does SwiftData still do merging like Core Data does? So basically, if you insert something in the background, can you get the persistent object ID, pass that back to the view, fetch your new object based on the persistent object ID without any merging going on?
Yes.
It works the exact same way as it does in Core Data.
Adding to that, the merging happens immediately.
The merging happens immediately, yes, because it's set to automatically merge changes from parent by default. Right, so it's identical to Core Data in that regard.
Okay.
Any other questions? It sounds like everybody is very excited for Bitterball, which I've just seen from the corner of my eye. They've entered the room. So thanks, everybody.
Bye.